Okay, in this video, I'm going to go over the Logic 1 worksheet, problems 1 and 2. All right, so let's start with problem 1 here. All right, so we're looking at the following statement. 5 is a prime number and 12 is evenly divisible by 5. Okay, what I mean by 12 is evenly divisible by 5 is that when you divide 12 by 5, there is no remainder, right? So it goes in evenly. You can see that's false, right? All right, so we're going to say that, so here in part A, it says that 5 is a prime number. We're going to call that, we're going to give that sentence that can be evaluated as true or false. We're going to give that the variable P. And we're going to use Q to stand for 12 is evenly divisible by 5. Okay, as you can see here, P is true, right? 5 is a prime number, so P is true. Q, as we know, is false. Okay. Okay, so we're going to write this statement using as a logical expression. Okay, so for this first one, we have P and Q. P and Q. All right, so now we'll determine the truth value of P and Q. Okay, this is as simple as saying, okay, when is an and true? An and is true when both parts are true, right? So this and that. So it has to be true and true. All right, so we already determined that P was true right here, right? P is true and Q is false. So the overall value of true and false is false. Okay, so here's where the important fact comes in. Okay, all mathematical propositions or statements are either true or false. Okay, so if P and Q is false, then its negation must be true, right? Because, so we determined here, right, that, let me write this out a little more formally. We determined here that P and Q is false, right? So if P and Q is false, then the negation of P and Q is the negation of false, which is true. So not P and Q is not false is true. All right, so you could write that, or you could simply just write let's see, we had P and Q is false, so not P and Q is true. Let's just write that there. Okay, so now we're going to use one of De Morgan's laws to distribute the not through the parentheses. All right, now this is not exactly, this is not exactly distribution, right? There's no distributive law going on here, but but De Morgan's laws, you can think of them like distribution. Okay, so Okay, so that's what we have here, right? The negation of P and Q is not P or not Q. So now we'll write this in plain language. All right, remember that we have P is a prime, P is 5 is a prime number. And Q is 12 is divisible by 5. Okay, I put the evenly in parentheses there because in a previous iteration of this class, when I taught this class before, I just wrote 12 is divisible by 5. To me, as a mathematician, when I say 12 is divisible by 5, I mean that it goes in evenly. But that confused students, so I put in the evenly. Okay, so you could just write 12 is divisible by 5 is what I'm trying to say there. Write your answer to part D in English. Is this a true statement? Okay, so now let's see, not P or not Q. So 5 is not prime. 5 is not prime, or 12 is not divisible by 5. Okay. Now, you might be saying, what's the point? So let me explain the point of this problem. Okay, so the main point is that all mathematical propositions are either true or false. And another main point is that De Morgan's laws allow us to give us a way of figuring out, of reasoning through what something means, what an and statement or an or statement, what they reasoning through what they mean after you negate them. Okay, so in part B, we see that P and Q is false, right? So we know that its negation must be true. But it's really weird to say it's not the case. So, just to think about the plain language here, right? So it's really weird to say it's not the case that 5 is prime and 12 is evenly divisible by 5, right? Think about if you were to say that to somebody somebody on the street, right? You're walking down the street and you say to somebody, it's not the case that 5 is a prime number and 12 is divisible by 5. They would just look at you weird, right? They'd probably look at you weird anyway because you're talking about prime numbers and divisible and all that kind of stuff, right? But let's say you're talking to somebody who knows a little math, all right? Is somebody who's not freaked out by the word prime. All right, they might. I think it's just weird to say it is not the case that this and this, right? So now in part D, De Morgan's law allows you to kind of get a better idea intuitively what you're saying when you say it's not the case that P and Q is true, right? So it's what is not P and Q, right? So P and Q right here, right? This is false, right? But we know that not P and Q, this right here, is true. So what does that mean? Well, now using the symbology, right, the symbols, we can push in this one, right, we can push the negation through to get not P or not Q. And now we can turn that back into plain language and see what this means. All right, so because they're equivalent, they have the same overall meaning, the same logical meaning. So now think about saying this: 5 is not prime, or 12 is not divisible by 5. Right, this is a true statement, right? We know this is true because its negation, P and Q, was false. Right here, we said that P and Q is false, so we know that its negation, the negation of P and Q is true. That's this right here. Okay, well, what does that mean? All right, well, not P and Q is equivalent to not P or not Q. Okay, that's the symbol. That's in symbols what it means. Okay, now taking it out of the world of symbols into plain language, we see that this is 5 is not prime, or 12 is not divisible by 5. Right, so that's the idea with these problems here. All right, so what am I doing there? Okay, let's get rid of that. Okay. All right, so now we'll play the same game here. All right, so this one we're dealing with OR, right? This is OR here. So we have P or Q. All right, so now determine the truth value. Remember that from above, we decided that P was true, Q is false, right? P, 5 is a prime number. 5, that is true. 5 is a prime number. And Q, 12 is evenly divisible by 5. That's not true. 12, when you divide 12 by 5, you get a remainder of 2. So it's not evenly divisible. Evenly divisible is your remainder is 0 when you divide it. Okay, so remember, OR is true when one or the other are true. So P or Q is true. So that means its negation must be false. Okay, so then you think about this. Like, what does it mean to say that it's not the case that 5 is prime or 12 is divisible by 5? All right, so it's a kind of a weird thing to sort through. So now we can use De Morgan's laws to help us sort through that. We know that not P or Q is equivalent to not P and not Q. Okay, so we transfer from the world of plain language here. We transfer from the world of plain language to the world of logic. We use logic to, we use symbolic logic here to push the negation through the statement. And now we take things back to the world of plain language. Okay, so 5 is not prime, and 12 is not divisible by 5. All right, and I know what you're saying right now. You're saying, hey, that's not true. It's not true that 5 is not prime and 12 is not divisible by 5. And you're absolutely correct. That's not true, right? And that's what we determined in part C, right? We determined that the negation of P or Q is false, right? We determined that the negation of P or Q is false. How do we know that? Because we knew that P or Q was true. And all mathematical statements are true or false. So if P or Q, right here, is true, then its negation must be false. Okay, well, what does it mean to say that's false? Well, we can use De Morgan's laws to get a better understanding of that symbolically, and then we can transfer that symbology into a sentence. And now we can see that, yes, in fact, that is not true.